Hello. So today we're going to be looking at the area of a segment of a circle. Now, we saw it at the end of looking at sector area that for a segment of a circle, it seems close to a sector area, but not quite. Because it's a part of a sector, but it's not the entire sector. So how do we find this area? Well, as you said, this is part of a sector. So I'm going to use two different colors here to try to denote some things that are going on here. So it's part of a sector. Here's our sector. Right? So our sector is within that blue area there. But we're not using this portion of it at all. We're not using anything in that green area at all. But what shape is that green area? That's right, it's a triangle. It is a triangle. And there's something special about this triangle, actually. Two of its sides. This side is the radius. This side is also the radius. What do you call a triangle that has two sides congruent? An isosceles triangle. Therefore, this is the radius, that's radius. This is an isosceles triangle here. This green part is an isosceles triangle. The blue area is a whole sector. We just need the segment though. Well, how would you find a segment? Well, looking at it, we know that the segment is what's left over if we take the whole sector and we take away this triangle. So the area of a segment is actually equal to the sector area minus the area of the triangle. And that'll be it for every time. Every single time that you create a segment, the segment is going to be a part of a sector because they'll have to have a central angle. The endpoints can connect to the radius somehow, or can connect to the center somehow, forming radii. And then that chord with those radii will form a triangle. And that's the portion that you're not looking at. So to find the area of that, there's always going to be a sector and a triangle involved. Now, generally, you will see this minus in this case. It's not always necessarily minus. Sometimes it's an addition of one. For example, if our chord was extended way down here instead, cut across, our sector will be everything above that. So it would be above 180 degrees. And the triangle would be beneath that. So that's the other way. So it could end up being plus. But there's always a sector and a triangle involved. It's very important to split this up so that you can see which part's the sector and which part's the triangle so you can know where to add or subtract. Okay? Well, let's finish this example here, shall we? Now that we have a couple of things set up, we know that this is a sector area minus the triangle in order to find the segment. Well, let's see what we know about each of those portions. Okay? Well, for a sector area, we know how to find a sector area. For a triangle, we know how to find the area of a triangle. So let's give this problem some more information, shall we? Okay. So I'll draw it up here again. And we'll just cut it off the same. We'll still say it's 120 degrees in there. And then this time we'll say that the radius is, let's make it simple. Let's call it 1 inch. Oh, let's call it 11 inches. Why not? A little more difficult. Okay. Well, when we're looking for this segment here, the shaded area, and we know that the sector area is equal to the measure of the central angle divided by 360 times pi r squared, pi times the radius squared. And for the triangle, we know that the radius is 11, so that means both sides of the triangle that create the 120 degree angle are both going to be 11 inches. And so area of a triangle can just be 1/2 the product of the two sides that are given here times sine of the angle. Okay? So in this case, we're going to subtract those two in order to find the segment. So we have the sector area. So we have 120 out of 360 times pi times 11 inches squared minus the area of the triangle, which would be 1/2 the product of the two sides times sine of the angle between them. Okay. And from here, I could just plug this into my calculator or input this into my calculator. And we end up with 121 over 3 pi square inches minus approximately, well, I can say exact first, 121 square root of 3 over 4 square inches. And if we want to the approximation after that, we will subtract those two entities and we would end up with approximately 74.32 square inches. All right, 74.32 square inches. And that's the area of that segment. All right. So area of a segment, very important to remember that this is just composing shapes. We have a sector area, which is a portion of a circle, and we have a triangle that we're taking out of it. Could be we're adding a triangle in. Depending on which one we're doing, we still have to know what the sector area is. We still have to know how to find the area of a triangle. And now we can combine those two things together by either, in this case, subtracting, could possibly have to add them. And then we would get our answer, get our result for what the area of the segment is. And that's all there is to it. Now, because I've mentioned twice that there might be instances where you might want to add it, I will show you that example. So pause if you need to. Okay. So I'm going to show you an example of a segment in which you may have to add instead of subtracting. And so that scenario would look like this. So if we had a circle, okay, and this whole thing here that's shaded, this was what we're looking for. Notice how the triangle is within the sector. So the sector goes from here all the way around to here. We add the triangle in there because that's where the chord cuts it off. That is now our segment. That whole thing there is still a segment. It's not this part that's not shaded. That part that's not shaded is also a segment, but in this case, it's not the one we're looking for. So to find the area of this segment, we could take the sector area because that would have an angle for it. Not sure what it would be, but it does have an angle for it here. The angle is greater than 180. And then we have the area of the triangle. And we just add those two things together to find the area of this segment. Okay. All right. So that is finding the area of a segment. I will see you soon. One important thing to note is that you now have enough tools to find the area of anything. You know how to find the area of a circle. You know how to find the area of a sector of a circle. You know how to find area of a triangle. And just with those, really two things, but we can call it three, you can now find the area of anything that's given to you. For instance, a segment is just a composition of those two things, or two basic shapes, circles and triangles. It's a composition of those two things together. If we added a, if we were to draw this with, rectangular bottom, kind of looks like a gumball machine. Maybe I want to find an area of that. We could do that now because this is just a rectangle underneath it. If I say that these are right angles, right? You know how to find an area of rectangle, you can just add that to the area of the segment. See, we can keep adding more and more different shapes into it and compose it to be something crazy. But keeping it basic and splitting it up correctly, we can find an area of it all day long. So yeah. So again, that's area of segments. And honestly, it's confidence to take the area of any shape. So yeah, area of a segment using sector area and area of triangles, which if you know those two things, you can find the area of a segment, you now have the capability to find the area of any shape given to you, any figure. So with confidence, I'll say I'll see you soon, and you got this one.